Hello, my name is Gabe. For this problem, we're given the equation of a hyperbola, and we're asked to find the vertices and then sketch the graph. So, looking at this equation here, we see that it's not in the standard form of a hyperbola. So our goal is going to be to first write this in standard form, and then we can gather information about it to go ahead and graph the hyperbola. So, just by looking at this equation, we might want to say that the standard form that we're going for is going to be something like y squared divided by a squared minus x squared divided by b squared is equal to 1. So this is the form that we want to try to write this equation in before we try to find the vertices or graph the hyperbola. So let's start by dividing each side of this equation by 225, because at least then we'll have a 1 on the right-hand side of the equation. So doing this division, we'll have 25y squared divided by 225 minus 9x squared divided by 225 is equal to 1. Now, as I said, here we have a 1 on the right-hand side, which matches up with our standard form of the equation of a hyperbola. But what we have to do now is we have to get rid of this 25 in front of the y squared and this 9 in front of the x squared. Because if you compare this to the standard form, well, we only have a y squared and we only have an x squared. There's nothing that we're multiplying y squared or x squared by. Now, the way we're going to do this is we're actually going to rewrite this 25 divided by 225 and this 9 divided by 225 in such a way that we don't have this 25 or 9 in the numerator. Now, what that's going to look like is going to be this right here. So we're going to rewrite this first term as a y squared divided by, we're going to rewrite 25 divided by 225 as 225 divided by 25. Now we're going to do the same thing for 9 divided by 225. So we're going to rewrite this term as x squared divided by 225 divided by 9. And this is still equal to 1. So now we can go ahead and we can simplify, and this is equal to y squared divided by 9 minus x squared divided by 25 is equal to 1. Now, what we see here is that we have the standard form of the equation of a hyperbola. And something we'll want to note is the transverse axis of this hyperbola is going to be vertical. And we can compare this form here with this equation here. And in doing so, we'll see a couple things. So the first thing we'll want to notice is that a squared is going to be equal to 9, or a is equal to 3. The next thing we'll want to notice is that b squared is equal to 25, which tells us that b is equal to 5. Now, here, we're only concerning ourselves with the positive square roots. So for instance, if we're looking at a, we have a squared is equal to 9. If we take square roots, we should get a is equal to plus or minus 3. But in this context, we're only worried about the positive values, and the same is true for b. So now that we know what a, b is, and we know that our hyperbola opens upwards and downwards, so opens vertically, we can go ahead and we can actually write down what our vertices are. So our vertices in this case are going to be the points 0, 3, and 0, -3. Now these just come from our a values. So let's go ahead and let's actually plot these 2 points. So we have 0, 3, and 0, negative 3. Now from here, our goal is to try to sketch the graph of our hyperbola, but we need a little more information than just 2 points. So what we're going to do is we're going to use the asymptotes to help us sketch the graph. So our 2 asymptotes in this case are going to be given by y is equal to plus or minus a divided by b times x. So what that's going to be is it's going to be y is equal to, let's do the positive one first, 3/5 x, and the negative one will be y is equal to negative 3/5 x. So let's go ahead and let's put these up on the Cartesian plane. So the first one, y is equal to 3/5 x. We're going to come up 3 and over 5. And let's imagine coming down 3 and over 5. So if I draw a straight line through these 2 points and the origin, we'll have one of our asymptotes. Now we'll want to go ahead and want to sketch the graph of our other asymptote, y is equal to negative 3/5 x. So that's going to be coming down 3 over 5. Now we can think about coming up 3 and to the left 5. Now we can connect these 2 points, making sure we go through the origin. So now we have our 2 asymptotes, and we have our 2 vertices. So now we can actually go ahead and we can sketch the graph of our hyperbola. So the hyperbola is going to pass through our vertices, and it's going to approach our asymptotes. So we can imagine starting at the point 0, 3, coming to the right and approaching our asymptote, and starting at this point, coming to the left, approaching the asymptote. And we'll do the same thing, except this time we'll start at the point 0, negative 3. So there's the graph of the hyperbola that was given by 25y squared minus 9x squared equals 225. Thank you.